Hello, so in this video, we're doing something a little bit different to the previous videos that we've done. Because in these cases, we're going to see what happens when there's a value here other than 1. So as we said in the very beginning, in order to do a binomial expansion and use this formula that we've been using, you have to have 1 plus or minus something. If you don't have a 1 already, you're going to have to make it a 1. So to see how we do that, let's take a look at part A. It says, use the binomial theorem to expand 8 minus 5x to the power of a third, where x, modulus of x, is less than 8/5, in ascending powers of x up to and including the term in x squared, giving each term as a simplified fraction. So basically just saying, expand this up to this x squared. But first of all, we're going to have to modify it so that we change this 8 into a 1. And the trick here is if I just write out our actual expression first, pop that to the power of a third. The trick is that you need to pull out a factor of 8. So if we want to pull an 8 out of here, when I pull out the 8, I'm going to have to put 1/3 on it as well. So it's actually 8 to the power of a third. And then inside, I'm going to have 1, because 8 divided by 8 is 1, minus 5/8 of x. Still to a third. So that's really important. We've pulled out a factor of 8, but we had to divide this 5x by 8 as well, which maybe makes it a tiny bit more difficult to play with, but not very, so it's fine. And then we can simplify that a bit more because 8 to the power of a third is like the cube root of 8, so that's just 2. So we get 2 sets of 1 minus 5 over 8x to the third. And that's it. So in this case, our x is our minus 5 over 8x, and our, our n is 1/3. So now we can just use this normal expansion on this. But remember, because we've got this 2 on the outside, we're going to have to put a big 2 and expand everything within this set of square brackets. So we're going to have this 1 here. Then for our n times x, we're going to have a third for our n times minus 5/8 x as our x. And then for this term here, our n will be a third. N minus 1 will be minus 2/3. And this bit on the bottom will just be 1 times 2, which is 2. And our x squared will be minus 5 over 8 x squared. And we only have to do it up to, I think, x squared, wasn't it? Yeah, x squared. So that's it. And we can close up those brackets now. And then we just simplify all of this. So if we simplify all of this, you can just simplify it with all of this kind of in here, or you can multiply it out straight away. So we do 2 times 1, which is 2. And then 2 times all of this, you could kind of put that in the calculator. And that would give us minus 5 over 12x. And then 2 times all of this stuff. And remember, they have to square the minus 5 over 8. And that would give us minus 25 over 288x squared. And that's it. We've expanded it. And that would, of course, continue on. But we only had to find these first few terms. So that's how we do part A. Yeah, we've expanded it like that. Then for part B, it says, use your expansion with a suitable value of x to obtain an approximation for the cube root of 7.95. Give your answers to 6 decimal places. So here we're only trying to find an approximation using our expansion. If we wanted to find the exact value of that, we would just put this into our calculator. But what they're asking us to do is use this expansion. So the way we want to do it is we basically want to make this here equal to this 7.95. Because remember, if this is cube rooted, that's the same thing as putting it to the power of a third. So what we're saying really is for part B is that 7.95 is equal to 8 minus 5x, because it's the bit inside the bracket. And we need to find out what our value of x is. And once we know what x value that is, we can plug that into here. So we can just rearrange this a bit by bringing the 5x to this side, and then doing 8, take away 7.95, we get 0.05. Then we can divide both sides by 5, and we get that. So now we can plug this into here. So doing that, we're going to get 2 minus 5/12 of 0.01 minus 25 over 288 sets of 0.01 squared. And we plug all that in. You'd want to pop that in the calculator, and that would give you 1.99585 to 6 decimal places. And that's it. So we used our expansion to solve this, because we knew that if we made x 0.01, then this bit here would equal 7.95, and so it would effectively be doing the cube root of 7.95. So I hope that makes sense. It's a little bit similar to some of the other things that we've already done, but it is different. So if you have any questions about it or there's anything not sure on, then do let me know and we'll explain that a bit more fully. But otherwise, hope it makes sense, and have a go at the MCQs at the end to make sure you practice it all, and I'll see you again soon.